Hello everyone, this is Rohan. Welcome back to our interview questionnaire series. Today we are going to discuss a very interesting problem based on linked list, and I'm going to show you the most easiest and the most efficient way of solving this problem. So let's start.
Hello friends, the problem that we are going to discuss today is about detecting a cycle in a linked list. So let's understand what does a cycle or a loop in a linked list mean. So there could be two types of cycle or a loop in a linked list. So first one is a full cycle where the last node of the linked list starts pointing to the first node of the linked list. So as you can see in the above figure that my node 5 has started pointing to the node 1 of the linked list. So this creates a full cycle in the linked list. And the other type could be a partial cycle where the last node of the linked list would start pointing to any one of the given nodes in the linked list. So in our case you can see that the node 7 has started pointing to the node 3 of the linked list. So we have a cycle from the node 3 to the node 7 of the linked list. So what a problem statement says is that you are given a linked list and we need to determine whether or not there is a cycle present in the linked list. So let's see what could be the constraints of this algorithm or this program. So the constraint of this could be like the list could be read only. So by read only we mean that we cannot mark any elements. So when you traverse the linked list you are not allowed to mark whether or not you have visited a particular node or not. So the second constraint could be like there is a limited amount of memory. So you cannot keep track of all the nodes that you have already visited since you have limited space and you're not allowed any extra space in your program. And the third and the most important constraint would be like the time complexity of the solution should be in order of n. So I mean you have to solve it in a best possible way. So while you're approaching this problem, you're trying to solve it. So what the interviewer could be observing in your approach. Oh, so these are some of the basic points. So like he could be observing what is your basic knowledge of the linked list operation. How do you traverse a single linked list? Okay, what all are the operations that you can perform on the linked list? Then the understanding of the problem. So by understanding of the problem, it means that whether or not you have taken care of all the things like the full cycle or the partial cycle or any other thing in the linked list that you think about. The third thing is whether all the edge cases are covered by the proposed solution. So the edge cases could be like if the list is empty or there is a single node in a list. So all those should be covered in your solution. And the most important thing is the initial way to approach the problem. So how do you start approaching this problem? How do you give a solution to this, or how do you think you'll solve it? So these are the things that the interviewer might be observing while you solve this problem. So guys, let's see how do we solve this problem in the most efficient way. So guys, what we'll be using here is the Floyd's cycle finding algorithm. So this algorithm was basically introduced to find a cycle in a linked list. So this approach for this algorithm, the approach that we take, so we have two pointers here. So one is the hare pointer and one is the tortoise pointer. So the hare pointer is moving with the double speed of the tortoise pointer. So by double speed I mean we increment the hare pointer by 2 positions and the tortoise pointer by 1 position. So what happens here if there is no cycle in a linked list? So when we start traversing the linked list, so we'll reach a point where the hare pointer will reach the last node of the linked list and he'll reach the next to be null at the last node. But if there is a cycle in a linked list, so what would happen is the hare pointer will enter the cycle of the linked list and simultaneously the tortoise pointer would also enter the cycle of the linked list, and while traversing, what would happen that at a certain position both the hare and the tortoise pointer would meet at one of the nodes in the cycle. So when they meet at one of the nodes in the cycle, we could be sure that there is a cycle in the linked list, and we could easily return our algorithm saying that okay, we have found a loop in a linked list. So let's see guys how it works. So when I start from here, so at the first point you can see my hare pointer moves to the node 3 and tortoise pointer to the node 2. So you can see the hare is taking 2 jumps. So in the next point you see it has gone to 5 and the tortoise has gone to 3. simultaneously 4, 7, then 5 and 9. Now after 9 you can see the hare has already entered the cycle. So the hare jumps to the node 5 from node 9 and the tortoise jumps from node 5 to node 6. And in my next iteration, you can see that both the tortoise and the hare meet at the node 7. So at this point we can easily conclude that there is a cycle in our linked list and we could return our algorithm accordingly. Okay, so like you can see here, this is my main function which detects whether or not there is a loop in the linked list. So what this function is given is a head pointer of the linked list, and what we do is initially assign the tortoise and the hare pointer to the head, and we start traversing till the hare pointer becomes null or hare pointer of next become nulls. So which means this condition would satisfy that we have reached the end of the linked list. Okay, so what we do inside our loop is we increment the tortoise pointer by 1 and the hare pointer by 2 positions. So you can see that we have done a hare pointer of next and a tortoise pointer is just a next. So if at any condition the tortoise pointer becomes equal to the hare pointer, here we are sure that we have entered a loop. We say that loop detected equal to true and we return the same from a function. So guys, let's try and debug this problem and see how it works on. So I'll just start debugging this. Okay, so I'll just enter dummy elements in my list. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So then it will ask me enter the start position. So this is just to create a cycle in a linked list. So suppose I want to start my loop from the node 4. So I'll just enter 4. So now you see I have a breakpoint here. So you can see that initially tortoise and the hare pointer are pointing to the head and both have the value 1. So let's just move over and see what happens. So you can see that after the first iteration, my tortoise pointer is pointing to 2 and the hare pointer is pointing to 3. So the hare pointer has moved by 2 positions. But still both are not same, so we continue the loop. So in the next iteration, you can see that here is pointing to 5 and the tortoise is pointing to 3. Still not the same, so we continue. So in the next iteration, tortoise becomes 4 and hare becomes 7. Still not the same, we continue. Tortoise becomes 5 and hare becomes 9. Let's continue. You can see that tortoise becomes 6 and the hare becomes 4. You can see that it has entered the cycle. And in my next iteration, tortoise becomes 7 and hare becomes 6. And again in my next iteration, tortoise becomes 8 and hare also becomes 8. So you can clearly see that at this point both the hare and the tortoise pointer have become the same. What we do is we say that loop detected equal to true and we return the same from our function. And once we continue, you can see that our output prints that okay, loop found in the linked list. And this is how we detect whether or not our linked list contains a cycle or a loop.
Thank you for watching the video. Please do like, share and subscribe, and do not forget to press the bell icon to get the future updates and notifications. And if you have any suggestions, please mention those in the comments. Thank you.